Now, another example for the force fit. It's a little bit different from the one we got earlier. Now we have the allowable compressive stress in the wall of the aluminum tube is given as 58.61 megapascal or 8,500 psi. So now we have been given the compressive stress. Its outside diameter is 50.8 millimeter or 2 inches, and the wall thickness is 1.65 or 0.065 inches. What will be the maximum amount of the interference between this tube and the steel sleeve that can be tolerated? The sleeve has an outside diameter of 76.2 millimeters or 3 inches. So let's understand what's happening here. The inner part is going to have the compressive stress on it of 8,500 psi. The outside diameter of this part, the part here, the outside diameter is given as 2 inches. So from here to here is 2 inches, and thus the B actually is equal to 1. The wall thickness is 1.65, so if I can define the B minus 0.065 inches, this will give me the A. And the C is simply going to be equal to 3 divided by 2. Now let's see how we're going to start the equation, the calculation. First, the step number 1 is finding the parameter that's being given to us. So we can calculate the A, the B, and the C. Okay, so you can see here that the diameter of the inner part, which is 2, minus 2 multiplied by 0.065, which is the thickness of the wall times 2, then divided by 2 to get the radius. So we go through radius, then we can start to do our calculation. So step number 2, we know that the sigma maximum are equal to negative 8,500 psi. Now, how are we going to use this one? The two equations we have for the stresses was for the sigma I and the sigma O. Of course, we have a compression stress, so we're going to use the sigma I equation. So only consider the inner member, and just remember later that for the conversion factor, every 1000 psi is equal to 6.89 megapascal. However, the sigma I is equal to 8,500 negative, and from there we can find the B, the P, because all the other parameters are known. So we can rearrange the equation, and we will find the P maximum, okay, in terms of the sigma maximum. So by solving, we find that the answer is going to be equal to 579.416 psi, or what equal to 3.93 megapascal. Now, step number 4, we need to check the increase in the diameter of the outer member due to tensile stress and the decrease in the diameter of the inner member due to compressive stress by using the two equations that we presented earlier. All the parameters are given to us, so I can find from there the sigma maximum, which is going to be half of the sigma O minus sigma I, or by rearranging the equation for the P, is going to be equal to the B multiplied by the P and multiplied by the rest of the equation denominator. For the steel, we know the E value and the VO value, the same thing for the aluminum part, and then we can put that in the equation. All the parameters are given now, so simply we can find that the value for the maximum delta is going to be equal to 0.0224 millimeters, and that's it. Now, just remember something that here we say 25.4 times 1, which is the millimeters per inches. That's just conversion factor. Okay, so that's it. Thank you very much for your time, and